Hi students, good morning. In the last class, I had discussed some problems related to the finite series. In this session also, we are continuing some other problems related to these ones. Let us start now. Okay. See that the problem is for r is 0, 1, 2, 3 and so on n, then prove that C0 CR plus C1 CR plus 1 plus C2 CR plus 2 and so on Cn minus R Cn is equal to 2n C n plus R. That is the result, and hence deduce the results. The first one is C naught square plus C1 square plus C2 square and so on Cn square is equal to 2n Cn. And the second one is C naught C1 plus C1 C2 plus C2 C3 and so on Cn minus 1 Cn is equal to 2n Cn plus 1. Now we are to proving these results. See the proof. See the solution. Now we are consider the expansions. Consider 1 plus x whole power n. 1 plus x whole to the power of n. What is the expansion of this one? That is nc naught plus nc1 x plus nc2 x square nc3 x cube and so on ncr x to the power of r plus so on plus ncn x to the power of n. That is same equation 1. That is equation 1. And another expansion that is 1 plus 1 by x whole to the power of n. 1 plus 1 by x whole to the power of n. In that expansion, what is the expansion is nc naught. In the place of x here we are writing 1 by x. Now in the place of x we are getting 1 by x. That is nc1 in the place of x here 1 by x. 1 by x plus nc2 1 by x square nc3 1 by x cube and so on plus ncr 1 by x to the power of r plus so on plus ncn 1 by x to the power of n. That is equation 2. Now we are product these two equations. Now we are writing product of these two equations. 1 into 2. We are writing the product of these two expansions. So in LHS, what is here? 1 plus x whole power n into 1 plus 1 by x whole power n. In RHS, we are producing these two terms. So the first expansion is nc naught plus nc1x plus nc2 x square nc3 x cube and so on here ncr x power r ncr plus 1 x power r plus 1 and so on plus ncn x to the power of n into the second expansion is that is nc naught plus nc1 into 1 by x nc2 1 by x square nc3 1 by x cube and so on here ncr 1 by x to the power of r plus ncr plus 1 by x power r plus 1 and so on ncn 1 by x to the power of n. Okay, now we are product these two expansions. Now we are writing the coefficient of x to the power of r. The coefficient of x to the power of r in the expansion. So here we are observing here NCR here NC naught. Product of these two terms, we are getting x to the power of r quotient. And next one is NCR plus 1, x power r plus 1, here NC1, 1 by x. Product of these two terms, we are getting x to the power of r. Now we are collecting these x to the power of r coefficients in the RHS. Now we are writing the coefficient of x to the power of r. The coefficient of x to the power of r. Say this is the equation 3. This is say equation 3. Now the coefficient of x to the power of r in RHS of equation 3. The coefficient of x to the power of r in RHS of the equation 3. This is the equation 3. Now we have taken, this is the equation 3. So this is the equation 3. Okay. Now we are collecting the coefficient of x to the power of r in RHS of the equation 3. Okay, what are the terms here? We are getting that is equal to the coefficient of x to the power of r in RHS of the equation 3. Now we are collecting the coefficients of x to the power of r. So here NCR, here NC naught. We are getting NC naught, here NC naught, NCR. Next, the two terms product. So here NC1, here NCR plus 1. That is here NC1 into NCR plus 1. Like that. These are the coefficients we are getting. In the last one, NCN minus r into NCN. NC before that and this before this and in the first equation NCN minus r into NCN. These are the coefficients of x to the power of r in RHS of the equation 3. So we are simply denoted by NC naught is nothing but C naught. We are writing C naught, CR plus C1, CR plus 1 and so on. We are getting CN minus r into Cn. Cn minus r into Cn. This is same equation 4. This is say equation 4. Now we are collecting the coefficient of x to the power of r in RHS. We are getting the equation 4. That is the coefficient of x to the power of r in RHS of the equation 3. Now we are taken LHS. Now we are taken LHS of equation 3. That is, what is LHS here? Now this is the 1 plus x whole power n into 1 plus 1 by x whole power n. 1 plus x whole power n into 1 plus 1 by x whole power n. That is the LHS of equation 3. Okay. Now we are writing this is 1 plus x whole power n. Your LCM, that is x plus 1 by x whole power n. That is nothing but 1 plus x whole power n into 1 plus x whole power n by x to the power of n. That is nothing but here 1 plus x whole power n, 1 plus x whole power n. That is 1 plus x whole power 2n by x to the power of n. So this is the LHS of equation 3. In that we are collecting the coefficient of x to the power of r in this equation. Now we are taking the coefficient of x to the power of r in LHS of equation 3. That is, we are writing here. What is the equation 3? LHS is LHS of 3. What is the 3? LHS of 3 is what is equation 3 in LHS is 1 plus x whole power 2n by x to the power of n. So now we are collecting the coefficient of x to the power of r in LHS of 3. That is 1 plus x whole power 2n by x power n. That is nothing but the coefficient of x to the power of n plus r. This x power n is moving to this side. Then we are getting x to the power of r into x to the power of n. That is x to the power of n plus r in the expansion of 1 plus x whole power 2n. So that is nothing but the coefficient of x to the power of n plus r in this expansion 1 plus x whole power 2n. So this can be written in the sigma notation, that is 2n cr x power r. Here r is 0 to 2n. Okay, so that is the x to the power of r. Here we are finding the coefficient of x power n plus r. So for x power n plus r, we are taken r is n plus r. So then the coefficient of, therefore the coefficient of x to the power of n plus r, x to the power of n plus r in the expansion of 1 plus x whole power 2n is equal to, that is the coefficient is we are writing 2n c, we are taking r is n plus r, that is n plus r. So the coefficient of x to the power of n plus r in this expansion, that is 1 plus x whole power 2n. So this is the sigma notation we are writing in brackets. Now this is the expansion of this one. In that we are writing the coefficient of x to the power of n plus r. This is the expansion of this one. So we are taken r is n plus r. We are getting the coefficient is the coefficient of x to the power of n plus r. So therefore the coefficient of x power n plus r in the expansion of 1 plus x whole power 2n is equal to 2n c n plus r. So therefore that is nothing but the coefficient of x to the power of r in LHS of equation 3 is equal to 2nc n plus r. So that is the coefficient of x to the power of r in LHS of equation 3 is we are getting 2nc n plus r. So that is equation 5. That is equation 5. So in that we are to finding the coefficient of x to the power of r in this expression. So in the equation 3 is the product of these two expansions. So now we are writing product of equation 1 and equation 2. In that we are writing the coefficient of x to the power of r in LHS, and we are finding the coefficient of x to the power of r in LHS. Now the same term coefficients on an equation are both are equal. So from that we are writing the x to the power of r coefficient in RHS is equal to the coefficient of x to the power of r in LHS. So these equation 4 and 5 are equal, since we are like term coefficients are equal of the equation. So now we are equating the equation 4 and equation 5. Equation 4 is the coefficient of x to the power of r in RHS of equation 3. And what is the equation 5? Equation 5 is the coefficient of x to the power of r in LHS of equation 3. Now from 4 and 5, these two are equal. Okay, now we are equating these two. We are getting the main result C0 CR plus C1 CR plus 1, C2 CR plus 2, and so on. Cn minus r into Cn is equal to 2n Cn plus r. Okay. Okay, now we are equating equation 4 and 5, we are getting the result. Okay, from equation 4 and 5, so equation 4 is the coefficient of x to the power of r in RHS of equation 3, and equation 5 is the coefficient of x to the power of r in LHS of equation 3. We are equating these two equations, we are getting the result. That is equation 4 is that is C0 CR plus C1 CR plus 1 plus C2 CR plus 2 and so on. C n minus r Cn is equal to, that is 2nC n plus r. So this is the our required result. This is the our required result. It has proved. Okay. Then using this result, we have to deduce the two results. That is, first one is now we have to prove the first one. That is, what is the first one? We prove that, what is the first result? C0 square plus C1 square plus C2 square and so on. Cn square is equal to 2n Cn. That is the proving the first result. Okay. Now in that, say this is equation. This is say equation 6. That is the proving main result. Okay. In that, we have to substitute put r is equal to 0 in this equation 6. In equation 6, we have taken r is equal to 0. Then we are getting here C0 into C0 plus C1 C0 plus 1 plus C2 C0 plus 2 and so on Cn minus 0 into Cn that is equal to 2n Cn plus 0. Put r is equal to 0 in this equation 6. Then here C0 that is C0 square. Here C1 C0 plus 1, that is C1 square. We are getting C2 square and so on. Cn square is equal to 2n Cn. This is the first result. Okay. Now the second one is now we are proving the second one. Now equation 2. What is the second result? In that we prove that what is the result we are proving here? C0 C1 C2 plus C2 C3 and so on. Cn minus 1 into Cn is equal to 2n Cn plus 1. That is we are to proving result. That is the second one. Now we have to take put r is equal to 1 in the equation 6. In that equation 6, we are taken r is equal to 1. Then we are getting here C0 C1 plus C1 plus 1 plus C2 C1 plus 2 and so on Cn minus 1 Cn is equal to 2n Cn plus 1. Put r is equal to 1. In equation 6, we are getting this one. So we are simplifying this one. Therefore, C0 C1 1 plus 1, that is C2 C3 and so on. Cn minus 1 Cn is equal to 2n Cn plus 1. This is our second result. So this is the main result, that is C0 Cr plus C1 Cr plus 1 C2 Cr plus 2 and so on. Cn minus r Cn is equal to 2n Cn plus r. So that is the main result we are to proving. So using that result, we are proving these two, C0 square plus C1 square plus C2 square and Cn square is equal to n Cn by putting r is equal to 0 in equation 6. Put r is equal to 1, then we are getting the second one. These two are our obtained results. Okay. Okay, see the next problem. If n is a positive integer, then prove that C0 plus C1 by 2 plus C2 by 3 and so on Cn by n plus 1 is equal to 2 to the power of n plus 1 minus 1 by n plus 1. So this is our proving result. See the solution. See the solution. So what is we are taken LHS? We are taken first. We have to taken LHS. That is later. That is say yes. Let capital S is equal to, what is LHS of the proving result? C naught plus C1 by 2 plus C2 by 3, C2 by 3 and so on, plus Cn by n plus 1. So that is the LHS of our proving result. Okay. Now this C0, C1, C2, Cn, these are the simply denoted. So now actually C0 is NC0. Here C1 is NC1 by 2. Here C2 is NC2 by 3 and so on, NCn by n plus 1. Okay. Now we are writing their values. That is NC0 value is 1, NC1 value is n by 2. Here NC2, that is n into n minus 1 by 2 factorial into 3. Next and so on. Here NCn value is 1 by n plus 1. Okay. Now we are writing here, now multiplying with both sides with n plus 1. N plus 1 into S. We are multiplying with n plus 1 on both sides. So n plus 1 into S in LHS. Now we are multiplying with each term by n plus 1. N plus 1 into 1. Here n plus 1 into n by 2, that can be written as 2 factorial. Next one is n plus 1 into n minus 1 by 2 factorial into 3, that is 3 factorial, like that and so on. Here we are writing n plus 1 by n plus 1. Okay. So that is here LHS is n plus 1 into S is equal to, what is here, n plus 1. This n plus 1 can be written as n plus 1 C1. So what is NC1 value is n plus 1 C value is also n plus 1. So n plus 1 C1 is nothing but n plus 1. Now this can be written as n plus 1 C2. This can be written as n plus 1 C3 and so on. This can be written as n plus 1 C n plus 1. That is nothing but 1. N plus 1 by n plus 1 is 1. That is n plus 1 C n plus 1. Now we are adding this one. Now we are adding the term n plus 1 S is equal to, in that RHS we are adding n plus 1 C naught and subtract the last term. Okay, n plus 1 C naught. Here n plus 1 C1, n plus 1 C2, n plus 1 C3 and so on, n plus 1 C n plus 1. Now in the first term we are adding n plus 1 C naught. In the last one we are subtracting n plus 1 C naught. Okay. Now what is the, observe this expansion, n plus 1 C naught, n plus 1 C1, n plus 1 C2 and so on, n plus 1 C2 and so on, n plus 1 C n plus 1. So what is the expansion of this one? So what is the expansion of 1 plus x whole power n? That is the standard binomial expansion. What is that expansion is, that is nc naught plus nc1 x nc2 x square and so on, ncn x power n, ncn x power n. So we are using this formula. So what is here? That is nothing but, here in the place of n is we are getting n plus 1 c1 c naught, n plus 1 c1. In the place of x we are here writing 1, n plus 1 c1, n plus 2 c2. In the place of x we are writing 1, then we are getting this expansion. In the place of n is n plus 1 and in place of x is 1, then we are getting this is the expansion, can be written as that is 1 plus, in the place of x we are coming 1, in the place of n is n plus 1. So that is can be this series can be written as 1 plus x whole power n. So here x is 1 and n is n plus 1. 1 plus x whole power n form we are writing. So this one is n plus 1 c naught. So what is c naught value is 1. N plus 1 c naught is value is also 1. That is n plus 1 c naught value is 1. So, okay, that is equal to here 1 plus 1, that is 2 to the power of n plus 1 minus 1. Therefore, what is here s is 2 to the power of n plus 1 minus 1 by this n plus 1 is moving to RHS side in denominator. Okay, so we are getting s is equal to 2 to the power of n plus 1 minus 1 by n plus 1. Okay, what is s? S is the LHS of the our proving result, and we are getting RHS is 2 to the power of n plus 1 minus 1 by n plus 1. So therefore we are, hence the proving result is C0 plus C1 by 2 plus C2 by 3 and so on. Cn by n plus 1 is equal to 2 to the power of n plus 1 minus 1 by n plus 1. So this is the result. Okay, this is the s is equal to 2 to the power of n plus 1 minus 1 by n plus 1. Okay, see the another problem. If n is a positive integer and x is any non-zero real number, then prove that the result here c0 plus c1 into x by 2 plus c2 into x square by 3, c3 into x cube by 4 and so on. Cn into x power n by n plus 1 is equal to 1 plus x whole power n plus 1 minus 1 by n plus 1 into x. Now we are proving this result. See that the solution we are taken LHS is s. Let s is equal to, so what is given LHS is we are taken s, that is c0 plus c0 plus c1 into x by 2 plus c2 into x square by 3, c2 into x square by 3 plus c3 into x cube by 4 and so on and so on. Cn into x to the power of n by n plus 1. So that is the LHS of the proving result. Okay, now we are writing this c0, c1, c2 is nothing but nc0, nc1. Okay, now we are writing c0 is nc0, here nc1, x by 2, here nc2, x square by 3, nc3, x cube by 4 and so on. So here Cn is ncn x to the power of n by n plus 1. Now we are writing their values. What is nc0 value is 1. What is nc1 value is n into x by 2. Here nc2 value n into n minus 1 by 2 factorial into x square by 3. Next, what is nc3? That is n into n minus 1 into n minus 2 by 3 factorial into x cube by 4 and so on. Ncn, that is value is 1 into x to the power of n by n plus 1. Okay, now we are writing here. So now we are multiplying with n plus 1 into x on both sides. Now we are multiplying with n plus 1 into x on both sides. Okay, now here n plus 1 into x into 1, that is n plus 1 into x. Here n plus 1 into x, x square by, that is 2, that can be written as 2 factorial. Next one here that is into n, here n. Okay, plus here n plus 1 into n minus 1 by, that is 2 factorial into 3, that is 3 factorial. Here multiplying with x into x square, that is x cube. Now like this and so on. Here n plus 1 into x power n, that is x power n plus 1 by n plus 1. Now we are multiplying with n plus 1 into x on both sides. Okay, then this can be written as here n plus 1 c0 into x. Here n plus 1 into n by 2 factorial, that is n plus 1 c2 into x square. Here n plus 1 n into n minus 1, that can be written as n plus 1 c3 x cube and so on. The last term is n plus 1 c n plus 1 into x to the power of n plus 1. Okay, now in LHS is n plus 1 into x into s. Okay, here sorry, this is n plus 1 c1, that is nothing but n plus 1 c1 is nothing but n plus 1. So now we are writing here n plus 1 into x into s is equal to, now we are adding n plus 1 c naught. Okay, n plus 1 c naught. The remaining are n plus 1 c1 into x. Here n plus 1 c2 x square and n plus 1 c3 x cube plus so on so on. N plus 1 c n plus 1 x power n plus 1. Okay. Now adding the term is n plus 1 c naught, that is the first term. Now that term is subtracting in last one n plus 1 c naught. We are observing the formula is, what is the formula here? The standard binomial expansion 1 plus x whole power n. Expansion is nc naught plus nc1x, nc2 x square and so on. Ncn x to the power of n. Okay, so this is the standard binomial expansion. In that where n is n plus 1, here n plus 1, then n plus 1 c naught, n plus 1 c n plus 1 c1 x. Okay, now we are in the place of n is, we are getting here n plus 1. So this expansion can be written as that is 1 plus x whole power n plus 1. This expansion is nothing but 1 plus x whole power n plus 1. Here minus n plus 1 c naught. What is the n plus 1 c naught value is 1. That is value is 1. Okay. Now this is n plus 1 into x into s. That s is equal, now n plus 1 x is moving to RHS side. Then we are getting 1 plus x whole power n plus 1 minus 1 by n plus 1 into x. So this is the our result. Here s is the LHS of the our proving result. So LHS is we are getting 1 plus x whole power n plus 1 minus 1 by n plus 1 into x. See the next topic, the binomial theorem for rational index. In the previous classes we are discussing the binomial theorem for integer index. In this session we are going to discussing the rational index. So what is the integer index? What is the binomial theorem? That is the standard binomial theorem, that is 1 plus x whole to the power of n. So what is the expansion of this one? That is nc naught plus nc1 x, nc2 x square and so on, ncn x to the power of n. So this is the, here n is a positive integer. Here in the last classes we are discussing the index is a positive integer. In this session we are discussing the binomial theorem for rational index. What is the binomial theorem for rational index? So in that here we are taken here n is a rational number, that is p by q. We are taken n is equal to p by q. Then we are getting the formulas. So the first one is 1 plus x whole power p by q. This is expansion. This expansion is valid when x must be less than mod x is less than 1. That means x lies between minus 1 and plus 1. So the expansion of 1 plus x whole power p by q. What is the expansion? See that the expansion is like that. Here This expansion is 1 plus p by 1 factorial into x by q. Next term, p minus q by 2 factorial into x by q whole square. And next term, p into p minus 2q by 3 factorial into x by q whole cube, and so on. In the r plus 1 term, that is p minus q, p minus 2q, and so on, p minus r minus 1 into q by r factorial into x by q whole to the power of r, and so on. So this is the expansion of 1 plus x whole power p by q. This expansion is valid when mod x is less than 1. This x is a real number that must be lie between minus 1 and plus 1. This expansion is 1 plus x whole power p by q is 1 plus p by 1 factorial into x by q plus p into p minus q by 2 factorial into x by q whole square, and p into p plus q, p plus p minus 2q by 3 factorial into x by q whole cube, and so on. So this is where taken general term, that is tr plus 1. What is the tr plus 1? R plus 1 term is p minus q, p minus 2q, and so on, p minus r minus 1 into q by r factorial into x by q whole power r, and so on. This is the infinite series. This is the infinite series. The expansion is infinite series. So next one, we are write this formula, that is 1 minus x whole power p by q. So what is the difference between first one and next one? So here 1 plus x, here 1 minus x. In the place of x we are writing minus x, we are getting this series. Then this expansion is here where x is minus x, we are getting here minus. So we are getting plus minus alternatively p by 1 factorial into x by q. Here minus x whole square, that is plus, we are getting here p into p minus q by 2 factorial into x by q whole square. Here minus x whole cube, that is minus, we are getting p minus q, p minus 2q by 3 factorial into x by q whole cube, and so on. Here we are getting minus 1 power r, p into p minus q into p minus 2q, and so on, p minus r minus 1 into q by r factorial into x by q whole power r, and so on, and so on. So here this is the general term, this is the r plus 1 term. So in this expansion 1 minus x whole power p by q, in that expansion what is the general term? This is the general term. Okay, next one, that is third one, that is the third one. So here we are writing 1 minus x whole power minus p by q. Here 1 minus x whole power minus p by q. Here in the index is negative rational number, and here also 1 minus x whole power minus p by q. So this expansion is like that. Here 1 plus, here the expansion is 1 plus p by 1 factorial into x by q. Here both are minus, here 1 minus x whole power minus p by q. Here and here there is a negative, then the terms are all positive. P by 1 factorial into x by q. Here p into p plus q. The terms are increasing, p plus q, p plus 2q, like that, by 2 factorial into x by q whole square. Here plus p into p plus q, p plus 2q by 3 factorial into x by q whole cube, and so on, plus we are getting here the general term p plus q, p plus 2q, and so on, p plus p plus r minus 1 into q by r factorial into x by q whole power r and so on and so on. So this is the expansion of this expression 1 minus x whole power minus p by q. Here minus and here also minus, then the terms are all positives. If the index is a negative rational number, then we are getting p plus q, p plus 2q, like that. So the numerator power and the numerators are increasing factors. Okay. Next formula is fourth one, that is 1 plus x whole power minus p by q. So in the above series we are getting all positives. In that the plus minus alternatively is coming, plus minus alternatively. So the same series, that is 1 minus p by 1 factorial into x by q plus p into p plus q by 2 factorial into x by q whole square. Here we are getting minus, p into p plus q, p plus 2q by 3 factorial into x by q whole cube plus and so on. So the general term here minus 1 to the power of r into p plus q into p plus 2q and so on, p plus r minus 1 into q by r factorial into x by q whole power r and so on. This is the general term for this expansion of 1 plus x whole power minus p by q. These four formulas are very important for finding the solutions of the second exercise. Okay, here we are observing these expansions. These expansions are valid. These expansions are valid when mod x is less than 1. That is the value of x is lie between plus 1 and minus 1. Okay, these are the very important formulas. So in that these are the general terms were taken. R plus 1 terms are general terms were taken. These are all infinite series. Okay.